Welcome to RoboMaster at Berkeley tutorial. This is from the computer vision group. So today we'll introduce a basic tool which is called OpenCV. It is really commonly used in the robotics field and machine learning field in terms of the computer vision and the processing. So now let's get started. The most basic thing is that you need to install the OpenCV. You can use OpenCV in both Python and C++. If you want to use it in Python, here we'll illustrate it in Python, right? So we're importing it by using import CV2. After you import CV2, you may want to use it with other tools such as NumPy and Matplotlib. Here, we'll introduce all of the examples in the Jupyter notebook. So let's get begin. So the most basic thing is read and show in the image. You can use cv2.imread and give it a file name to read the image. Image.shape will give you the dimensions of the image. If you want to know the color intensity at a specific pixel, you can just index into the pixel by using the image indexing. In OpenCV, when it is reading the image, the color space would be BGR. But for human beings, we commonly use RGB. So how to convert the color channels? The way to convert it is by using cv2.cvtcolor, given the image and the two channels you want to convert. So here's the example. We are converting the original image from the BGR to the RGB color space. Now let's introduce some basic tools in the OpenCV which are really commonly used. The first thing is called the thresholding. If you want to subtract a feature from the image, you only want the things you need from the image, we always apply the thresholding on the image so that we can only maintain the things we need. The image will be converted to the black and white image. So if you want to apply thresholding, you want to first convert the image to a grayscale image by using the color space converting we talked about before. And then cv2.threshold, this function will apply the thresholding on the image. The first parameter is the image you want to convert. The other thing, the second parameter is the threshold. Here it is 127. So what does it mean? All of the pixels who has value smaller than 127 will be assigned value 0, and all the pixel values greater than 127 will become 255, which is white. After we apply this thresholding, the image will look like this. Remember, there are some rules applying to the threshold. Here we're using the binary rule, so it's only black and white, two colors. But there are other thresholding rules. You can go to check the OpenCV thresholding tutorials. Sometimes we not only want to deal with the grayscale image, we also want to deal with the color image. Suppose we just want to find the red parts of an image. Let's say in this case, we want to use the red parts to get the stop sign in this image. Now, thresholding doesn't work because if we apply the grayscale onto the image, we're losing the information of the color space. Now we have a tool which is called masking. If you want to use mask, here we need to introduce another kind of color space which is called HSV. It's formed with hue, saturation, and value. We want to use HSV because it is better for identifying contrast in image. So first, we want to convert the image from RGB color space to HSV. Then you need to figure out the masking color range for the image. In this case, we want to mask out the red pixels. So we need to determine the lower bound and the upper bound for the HSV value. So here it's the lower bound, it's the bounds. And then if I want to determine the mask on the original image, you're going to use cv2.inRange and giving it the lower bound and the upper bound. So it will return you the same size as the original image, but applying the masking on it. How to actually apply the mask onto the original image? You can use a bitwise AND. Because the mask only contains 1 and 0, which means 1 it is in the range, 0 it is not in the range, and then you can use a bitwise AND onto the original image so that it only maintains the color space you want. So in this case, we only want the red color. So only the red pixels will still remain to be 1. All the other pixels will become 0, so they will become black. So now we get the stop sign from the original image. It is really common use for us because when we are dealing with robotics, for most of our image processing, we just want to process the robot itself. We don't want to include the background. The masking will help us to using the color feature on the robot to just process the robot object itself. Another really common use thing is the edge. To human, edges are visually obvious. We can easily tell where one object stops and another starts. But what about to the computers? In simple terms, we can detect edges in images by just finding areas where there's a really sharp change in terms of the color. So in this case, there is a really big contrast between the black and white color, so we know there is an edge there. But it's actually more complicated in the OpenCV. But OpenCV provides a wrapped function which is called canny edge detection for us to detect the edge. In this case, we still need to convert the image to the grayscale because canny edge detection is working on the grayscale image. And then you can apply the canny by using cv2.canny. Here is the result. But sometimes the image has really complicated edges of the objects. How do we smooth the image, and how do we have a much better edge detection? One way is to apply what we just learned, the masking, onto the image first. So in this case, if we want to shape out the stop sign by using the edge detection, probably we want to mask out the stop sign first. Because the background has a lot of trees, so there are a lot of complicated edges on the background. So we are masking out the stop sign first and then apply the edge detection on the stop sign. How to do it? It's the same thing. We're applying the mask first. Because the mask image will output a grayscale image, so we can directly apply the canny edge detection onto it. There's another way to deal with, actually we usually use these ways combinedly. There's another way to deal with the noise in the original image so that we can have a much better performance of the edge detector. It is called filtering. The commonly used filtering including Gaussian blur, averaging, and bilateral filtering. In this case, we will illustrate the Gaussian blur. So basically, the filtering will first apply a smooth onto the image so that it can smooth the features on the image. We will have a much better edge detector later. So the way we are doing it is we're first applying Gaussian blur onto the original image. Now we have already smoothed our image. And then repeating the same process, apply the mask on the image and then apply the canny edge detection onto the image. It performs much better here because the edges are getting smoothed before. The last thing we're going to talk about is the contours. Another useful tool in the object detection is the find contours in the OpenCV. Contours are basically closed curves joining continuous points of the same color or intensity. These curves will typically be boundaries around shapes. Let's see some examples. So here, if we want to shape out the whole stop sign, we can apply a mask onto it, repeating the same process to have the canny edge detection. And now we can have find contours to actually contour out the whole stop sign. The way we are doing it is after we have the edge detection, we can use find contours, cv2.findContours. And in this case, it will return us the contours on the canny detection image, which in this case, the shape is just the stop sign. There's another way we can use the contours. Because after the contours, we can know the leftmost, topmost, rightmost, and bottommost pixel of the object we want. So now we have the bounding box of the of the object in the image. So we can get rid of the whole background and just crop out the object we want by using the contours we find. In this case, if we want to have the bounding box on the stop sign, we want to figure out the biggest contours, because to our human eyes we know that the stop sign has the biggest contour. So in this case, we are finding the largest contours. We first find all the contours, then apply a large contour function onto it to determine which contour gives us the maximum area. There is a function in OpenCV called contour area, which given a shape, it will directly give you the area of that shape, so that we can determine which one will be the maximum. After we have the maximum area, we will know the bounding box of the object. So now let's just use the bounding rect on the contour so that it will chop out the image according to that bounding box. So thanks for watching the basic tutorial for the OpenCV 2. If you want to learn more stuff, you can always go to OpenCV 2 contours. Hopefully you like it. Goodbye.